Welcome back. This is the second video of our Airframe and Powerplant crash course series. In this video, we'll continue looking at ground operations and we'll be talking about some of the equipment used in aircraft maintenance. There's the auxiliary power unit, the electric ground power units, and we might even get to the hydraulic ground power units. Big airliners have some systems that are not absolutely crucial, but make them more reliable. Years ago, aircraft manufacturers and operators figured out that installing a small turbine engine in an aircraft's tail is a great way to provide an extra level of safety, convenience, and comfort. Hiding inside the tail of most airliners is an extra engine called an auxiliary power unit, or APU. The APU is a form of a turbine engine called a turboshaft engine. Unlike the aircraft's main engines, the APU outputs almost no thrust. Most of the power produced is used to run an electric generator and provide pneumatic air pressure. The APU is usually run on the ground during passenger boarding and deplaning. It provides pneumatic pressure for air conditioning and, more importantly, starting the main engines. Here you see the route from the APU to the various systems. Here, the APU eliminates the need for an external power source, a GSE, ground support equipment. Similarly, in the event of a pneumatic malfunction in the main engines, the APU can provide compressed air for cabin pressurization and airframe ice protection. The APU drives a generator that in turn powers the electrical system of the aircraft when the main engines are off. When the APU of the aircraft is not operating, electrical power and air pressure can be provided by ground support equipment. The APU's electrical generator can be used during flight in case one or more of the aircraft's main generators have a problem. Ground support electrical APUs vary widely in size and type. However, they can be generally classified by towed, stationary, or self-propelled items of equipment. Some units are mainly for in-hangar use during maintenance. Others are designed for use on the flight line, either at a stationary gate area or towed from aircraft to aircraft. The stationary type can be powered from the electrical service of the facility. The movable type ground power unit generally has an onboard engine that turns a generator to produce power. All aircraft use batteries as an emergency backup or standby source. Some aircraft have two electrical connections, one to connect to DC GSE and the other to connect AC GSE. However, large aircraft bring only AC ground support equipment connections, and lighter aircraft bring DC ground support equipment. AC and DC electrical connections are designed to connect in a way to avoid electric shock. There is no way to connect the AC receptacle to the DC or vice versa. The towed power units vary in size and range of available power. The smaller units are simply high-capacity batteries used to start light aircraft. In aviation, these connectors are standard for all aircraft as defined in ISO 6858. Here you see the female connector receptacle and the male connector plug for a DC connection. Many aircraft require 28 volts of direct current and 115 volts 400 Hz of alternating current. The electric energy is carried from a generator to a connection on the aircraft via three-phase 4-wire insulated cable capable of handling 261 amps. The AC plug, as you see, has 6 pins. 3 thick pins carry the phases of electric current A, B, and C, and the fourth is a neutral pin. The other 2 smaller pins serve as guides and are called pin E and F. All aircraft that use AC current as the main source of energy use this type of receptacle. The position of the receptacle varies according to the aircraft, but in most cases, this connection is located on the right side of the aircraft and outside the hazardous suction area of the engine air intakes. As you can see, the connection cables are heavy and unruly and require the support of 2 or more technicians to connect to the receptacle. When using ground electric power units, it's important to position the unit to prevent collision with the aircraft being serviced or others nearby in the event the brakes on the unit fail. Well, that concludes our little presentation for today. Until next time, stay healthy.